All right, folks, we're going to keep going here with chapter 2.5, looking at the object-oriented model here. As we've looked at a couple different ways of doing our entity relationship modeling, we're kind of still evolving and, again, trying to fit as much as we can into a picture. So we might often talk about this object-oriented data model. What's great about this is that object-oriented, this is generally how we program. So when our programmers write applications that interact with databases, they're done in an object-oriented manner. And what's great about the object-oriented data model is that it's going to include even more meaning, even more attributes, even more ways of interacting with the objects in the model. So it's considered a semantic data model. Semantic being that it has meaning. Right? So we're able to include more meaning in our model here. So we typically talk about, again, these entities. These are our tables here. And as I mentioned, kind of with that UML model, we get the name of the entity. So we might have like employee. And then we're going to get all the attributes listed. So we might have their date of birth. We might have their salary. We might have their hire date. We might have their position. All sorts of those sorts of things. And then in this third section, so, and again, these are going to get a little large, and that's okay. The third section, we're going to include the things that are part of the employee class. So as we interact with an employee in the programming side of things, what are ways that we interact with it? So sort of its behavior. So these are the methods here. So we'll have methods. These are the ways of interacting. These are the attributes. Here, these are going to be our methods. So things we can do with an employee, right? We might be able to give raise. And the give raise method here is probably going to be changing their salary, right? So these ways of interacting sometimes work with their attributes here, or might have like promotion, right? And then it might change their position, title, something like that. So we get different ways of interacting with them. The other really cool thing when you deal with object-oriented applications and object-oriented programming is that you get this idea of inheritance. So we might have a class hierarchy. So you might have a class for person, and then person then could have all those attributes for name, for date of birth, anything else we want to track for people. And you say an employee is a person. And then we might have a customer. A customer then is a person. So we're able to define these relationships when through inheritance, you would be able to get all of the attributes of whatever you're inheriting from, and then you can add your additional specialized versions. Again, if you haven't done any programming, that probably doesn't make a whole lot of sense. Don't worry too much about it. It's a way that we can encapsulate or show all of these details in a single picture here. So that's our object-oriented data model. It's really cool. Again, the more details we can get into the model, the easier it's going to be to actually build it, right? Think of it like building a blueprint. If all you have for your blueprint when you have to build a house is, hey, here's a square, and you might say, here's bedroom 1, and over here's bedroom 2, and over here was like kitchen, right? You might have a hard time building this house because there's not a whole lot of details here. Like, well, what's in here? Where are the doors? Where are the windows? That sort of thing. So the more details we can put into our models, the easier it's going to be to build it here. So again, as we look for more ways to represent data, it can be a little bit tricky. So all of this so far has been structured data. Structured data. We know exactly what the data is, right? It's a date, it's a time, it's a numeric value, it's a bunch of text, whatever that happens to be. We're able to define all of that. As we need to store more flexible types of data, we look at using this sort of thing called XML is one, or JSON is another. It's sort of a, oops, that's kind of ugly. That's a J there, JSON. It's a semi-structured data here. So this is semi-structured. Now, there's some structure within the XML, the extensible markup language. There's some structure within the JSON, the JavaScript object notation, I want to say. Maybe I should Google that, make sure I'm saying the right thing. And you're able to store more data, more objects, more things there, but it's less structured. So as we look at moving into some of those other models, they're a little bit more complex. It's a little harder for us to map all of the details out because we only have some structure. And then moving beyond that into our big data, and no SQL, which the no here is funny. That's not only SQL. It doesn't mean there's no structured query language, or structured query language. It's just there's not only that. There's additional things that we can do. So, and this, a lot of the worldwide tech, the global tech, is kind of pushing this because we have more and more and more data. As we get our Internet of Things, we have more devices collecting data. This term big data is a little bit funny, but generally we describe big data as something fitting the 3 V's, right? It refers to the volume of data. So you need to have enough volume of data that is so large that it's not able to fit in a traditional relational data model. The velocity of data. So not only are we getting large amounts of data, but the speed at which we're gathering the data is important here. So think about the millions and millions of interactions on Facebook or Twitter or Instagram that are happening all the time, right? Just that amount, not just the amount, but the velocity, how fast that data is coming and growing. And then also we look at the variety of data to be considered big data. Really, we're getting lots of different data, different formats, data from different sources, perhaps, that we're putting together here. Now, an interesting thing about Facebook is, although they know a whole lot about us, they actually go out and buy additional data about us so they can better target their ads. So Facebook is not only getting the data that we're putting in, they are buying additional data, marketing data, to learn more about us, to better give us targeted ads. And honestly, some of their ads are cool. I guess you folks probably don't use Facebook because it's for us old people now. But they do a really good job of finding things you're interested in and tailoring those ads to you. So if you can fit these 3 V's, then it's typically a big data thing. So just because you have a lot of data, just because you have a large volume, doesn't necessarily mean it's this, quote, big data idea. Right? You might have a lot of fast data that we're bringing in from a lot of different sensors. Doesn't necessarily mean it's big data. You might have a variety of different sources you're putting together, but we kind of look at all 3 of them together to say, yeah, this is really sort of a big data issue. And this has been pushing the boundaries of our traditional database management systems because we just can't handle millions and millions and millions of rows of different formats, some structured, some non-structured data, just every day growing and growing and growing. We need different ways of handling our data. So some of that's evolved is this not only SQL or NoSQL technology, so that we are able to do additional things, not just the regular structured query language, not just the usual that online transaction processing, right? We're not storing all of these pieces of information in our general enterprise transactional database. Right? That's, hey, okay, here's I sold this, here's I sold this, here's I sold this, you clocked in, whatever we're storing here. We're not storing it in that sort of data. And even the online analytical processing, our data analytics tools, are tricky when we deal with this sort of variety of data, the different formats of data. The approach that we had with those was still very structured. So it was a little tricky in dealing with some of those. So one of the big tools that came out of here is Hadoop. So Java-based, open source, it's the idea that it's really a distributed computational framework. We use a lot of low-cost hardware to make clusters. So started with Google, they're doing their distributed file system parallel processing. The idea that we can take a big problem and break it down and spread it across lots of different hardware to manage it here is really cool. So they have the Hadoop distributed file system, Hadoop distributed file system, and MapReduce. MapReduce is really cool. It's a technique of trying to solve problems here. With this file system, right, the idea is it's very fault tolerant. It's storing lots of data at high speeds. We're storing across multiple nodes. We have a lot of redundancy going on here. Again, not a solution for every problem, but for specific problems when we're dealing with this big data sort of thing, it's going to work well because we have different nodes and we get ways of interacting with it that work out pretty well because we can distribute it more locations. And again, using cheap hardware is kind of the idea here. Map reduce was the idea of how do I take big problems and break them down to kind of divide and conquer. So it's a way that we can process big data where the big problem gets distributed across lots of different processing nodes, and they all get to do a little chunk of that processing, and then we put it back together when we're done. So it's mapping the job out and then reducing it down to those smaller functions we can operate, and then building it back up when we have our solution. We'll get more into big data. At the end, we got one chapter we're going to talk about, and if you're interested, we have an entire course on big data as well that's new. I think we're going to run it this winter, if I remember right. So that's coming up. That one's pretty cool. Actually, we can Google that one real quick, right? Grab a browser tab. That's in our catalog. Here we go. As you can tell, I go to this course descriptions page more often than not. This is my history here. Let's see if this one will load for us. Come on. Let's search. There it is, big data and no SQL systems. So look at architecture, design, implementation, support of systems, which is really cool. So lots of fun stuff in this course specifically on that topic. Again, we'll touch on it again near the end, but for now, this is just kind of introducing the way that our data models have evolved to deal with different problems. Right? The relational data model is still great. We still run our transactional day-to-day databases on it. We can still do traditional analytics on it. But as we deal with this big data issue, we need different tools for solving those sorts of problems. Right, and then nice little summary. Again, the idea, kind of we've gone from older models to newer ones. We've worked our way from this hierarchical, that's probably don't even need to draw it out, to we've for a long time lived in this relational data model from the 70s on to the 2000s and so on. Just recently, in the last decade or so, really, it started, I guess, 2009, but it's really been growing in speed throughout the 2010s to deal with big data and this not only SQL way of analyzing data, storing data, managing data, and dealing with it. And the data model's job is to try and make sense of all of the data so that we can build upon that. So we need a way to model it for us to be able to use it.